Okay, in this video, we're going to go through the first section of the Rust book, the Rust programming language book. We're going to do the whole getting started section here. So let's get started with getting started. Let's start your Rust journey. There's a lot to learn, but every journey starts somewhere. In this chapter, we'll discuss 1. Installing Rust on Linux, Mac OS, and Windows. 2. Writing a program that prints Hello World. And 3. Using Cargo, Rust's package manager and build system. All right, let's hop over to the next page here. So, installation. I think for this page, I'm not actually going to run any of the installation commands. I already have Rust and Cargo and all that jazz installed, and so we're just going to read through. So installation. The first step is to install Rust. We'll download Rust through RustUp, a command line tool for managing Rust versions and associated tools. You'll need an internet connection for the download, naturally. Note, if you prefer not to use RustUp for some reason, please see other Rust installation methods page for more options. That's interesting. I actually didn't know that. I just thought it was all RustUp, and good to know. I don't think I actually, in the current state of things, have a use case for doing anything other than basically using RustUp and Cargo the way they're designed to be used, but it's good to keep that in mind. Little option in the back pocket there. The following steps install the latest stable version of the Rust compiler. Rust's stability guarantees ensure that all the examples in the book will compile and will continue to compile with newer Rust versions. That compile will continue to compile, I should have said. The output might differ slightly between versions because Rust often improves error messages and warnings. Okay, fair. That's not necessarily a bad thing. The output might differ. Oh, I just read that. Okay, we're good. Stable version. All right, command line notation. In this chapter and throughout the book, we'll show some commands used in the terminal. Lines that you should enter in a terminal all start with the $. You don't need to type the $sign character. It's the command line prompt shown to indicate the start of each command. Lines that don't start with $ typically show the output of the previous command. Additionally, PowerShell specific examples will use a greater than symbol instead of a $sign. So technically, I got this like weird inequality-like looking symbol that's green there, which might make you think at a glance that this is PowerShell, but if you're familiar with Ubuntu, you'll immediately recognize that this is not PowerShell. This is Bash, but I've got a special command line tool that modifies my prompt. So Starship, if you're curious. You don't need Starship, though, to follow along, so don't you worry about your prompt. If it's a $sign, great. If it's an inequality sign, great. If it looks like Starship, then great. Or something else. Should be fine. So, installing RustUp on Linux and or Mac OS. That would be or, not and. If you're using Linux or Mac OS, open a terminal and enter the following commands. So you got curl, proto, equals HTTPS, so this is the protocol for how you're going to go get it, and I guess this is specifying where to get it from, and then I'm not really sure with this flag, and then piping it into Bash, I guess is the gist of it. The command downloads a script and starts the installation of RustUp tool, which installs the latest version of Rust. You might be prompted for your password. If the install is successful, the following line will appear. Rust is installed now. Great. Great. Okay. You will also need a linker, which is a program that Rust uses to join its compiled outputs into one file. It is likely you already have one. If you get linker errors, you should install a C compiler, which will typically include a linker. I actually didn't know this about Rust. Every time I've used Rust, this has been a non-issue. I've never seen those linker issues. I have written enough, C code to know about linkers and needing to set up header files and stuff like that. But yeah, actually, it's completely news to me that Rust could run into problems with this. If you get linker errors, you should install blah, blah, blah. Okay, a C compiler is also useful because some common Rust packages depend on C code and will need a C compiler. Just out of my curiosity, do I have GCC installed? No, I don't. Or G++? Apparently not. Good to know. Okay, a So on Mac OS, you can install a C compiler by running xcode select -- install. Linux users generally should install GCC or Clang according to their distribution's documentation. For example, if you use Ubuntu, you can use the build essential package. Good to know. Weird thing is, I don't think we're going to actually run into any compiling errors, even though I don't think I have GCC. That's so interesting. I wonder what I've actually got here. Okay, installing Rust up on Windows. So I actually do use Windows for work, and so this is still relevant to me. On Windows, go to this URL, basically with an install thing on there, and follow the instructions for installing Rust. At some point in the installation, you'll be prompted to install Visual Studio. This provides a linker and the native libraries needed to compile programs. If you need more help with this step, see the blah 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 link. Great, good to know. I'm curious. So they've got these things with C compilers. But then there's also Zig, and I'm not suggesting that you should go use Zig for this instead, but I'm curious if you could use Zig, the Zig compiler, whatever that is, for this purpose as well. Because Zig is supposed to be able to compile C code, and I wonder if it's capable of providing that linking behavior as well. Not sure. Honestly, not sure. Okay, the rest of this book uses commands that work in both a commands.exe file and PowerShell. If there are specific differences, we'll explain which to use. Okay, good to know. So troubleshooting. To check whether you have Rust installed correctly, open a shell and enter this line. Let's do it. Rust C, this is the Rust compiler. Checking that version. Look at that. We got 1.87 point whatever, with some kind of hash that I'm not sure which hash style that is, and a date, which is probably the date of that release. Okay, if you see this information, you have installed Rust successfully. If you don't see this information, check that Rust is in your path system variable as follows. I don't think I'm going to type that one in PowerShell. Use echo, environment, path, that's cool, and Linux, echo, path, that's fine. If that's all correct and Rust still isn't working, there are a number of places you can get help. Find out how to get in touch with other Rustations, a silly name we call ourselves, on the community page. Okay, good to know. Actually, I'll take maybe a quick peek. Which community page is this? Oh, okay, this one. All right. Great. Updating and uninstalling. So once Rust is installed via rustup, updating to a newly released version is easy. From your shell, run the following update script. I think I just did this recently, so I don't expect any updates. Oh, you know what? There are updates here because, what was it? I wasn't updating rustup. I was doing rustup self update, and there wasn't updates for rustup self. We'll get to that in just a moment here, I think. But to uninstall Rust and rustup, run the following uninstall script from your shell. Okay, we're not going to uninstall it. We're going to keep it installed. Now we got to do the little waiting thing because I didn't consider that maybe there were actually updates. Look at that. Clippy and Cargo and Rust docs, and now we're done. That was it. That's easy. And it cleans up the downloads and temporary directories. Love it. I love it. Okay. To uninstall Rust and rustup, run the following uninstall script from your shell. We're not doing it. Rustup, self uninstall. Come on, you don't need that command. You're going to stay with using Rust. Don't uninstall it. Don't do it. Local documentation. The installation of Rust also includes a local copy of the documentation so that you can read it offline. Run rustup doc to open the local documentation in your browser. All right. Rustup doc. Okay. Would if I could, but I'm not going to fix that right now. Okay. Anytime a type or function is provided by the standard library and you're not sure what it is or does, or how to use it, use the application programming interface API documentation to find out. Fair enough. Text editors and integrated development environments. This book makes no assumptions about what tools you use to author Rust code. Fair. So like Notepad? Going to do it in Notepad? I don't think we'll do it in Notepad. Just about any text editor will get the job done. However, many text editors and integrated development environments, IDEs, have built-in support for Rust. You can always find a fairly current list of many editors and IDEs on the tools page on the Rust website. I didn't know that. Okay, fair. So you got the VS Code, of course, and my favorites, Vim and NeoVim. I have not tried Rust over. Actually, I hadn't even heard of it until just now, to be completely honest. Helix I've heard of. Emacs, of course, just the ancient arch nemesis of us Vimeos. And then Sublime Text, of course. Heard of that one. Visual Studio, yep. And Zed. Also heard of, but still kind of new. Like, I don't know much about it. Okay, we're not going to review those tools right now, though. Let me see. So, working offline with this book. In several examples, we will use Rust packages beyond the standard library. To work through those examples, you will either need to have an internet connection or have downloaded those dependencies ahead of time, which, fun fact, requires an internet connection. To download the dependencies ahead of time, you can run the following commands. We'll explain what cargo is and what each of these commands does in detail later. So, I mean, we could, but I think we'll actually we have an internet connection, so I don't think we need to cache them. This will cache the downloads for these packages, so you will not need to download them later. Once you have run this command, you do not need to keep the get dependencies folder. If you have run this command, you can use the -- offline flag with all cargo commands in the rest of the book to use these cached versions instead of attempting to use the network. I don't really have a use case plan for this because usually when I'm coding, it usually is somewhere where I have internet connection. And so, I don't know. I guess it's good to know, but I'm not likely to do that anytime soon. All right, we're going to get into something where I think we might actually write some code. Let's get into it. I'm excited. The first running Rust code that we're going to do out of the Rust programming language book. So Hello World, classic program. Now that you've installed Rust, it's time to write your first Rust program. It's traditional when learning a new language to write a little program that prints the text Hello World to the screen. So we'll do the same here. Note, this book assumes basic familiarity with the command line. Rust makes no specific demands about your editing or tooling or where your code lives. So if you prefer to use an integrated development environment IDE instead of the command line, feel free to use your favorite IDE. Cool. Many IDEs now have some degree of Rust support. Check the IDE's documentation for details. The Rust team has been focusing on enabling great IDE support via Rust Analyzer. See Appendix D for more details. Yeah, we'll get to Appendix D, and you may have noticed in some of my other videos that I already have Rust Analyzer set up for NeoVim, but it's available for many IDEs, including if you're on VS Code or whatever. You should be good. Okay, so creating a project directory. You'll start by making a directory to store your Rust code. It doesn't matter to Rust where your code lives, but for the exercise and projects in this book, we'll suggest making a projects directory in your home directory and keeping all of your projects there. So I already do that, and I'm nested inside of a bunch of paths down to this reading the Rust book path, so that's fine. And actually, we'll want to go into getting started, I believe, and I've already set up a path, but I have not written any code here. This is just an empty directory. So what do we want to do here? Open a terminal, enter the following commands to make a project. We're not going to do that, and a directory for Hello World project within the projects directory. So we'll do that. We'll make dir Hello World. And let's go into that directory. We're ready to go. For Windows commands, enter this instead. User profile projects. I mean, this stuff looks basically the same, doesn't it? All right. So writing and running a Rust program. I feel like, I wonder if anybody is actually, this is kind of a tangent. I wonder if anybody has learned Rust to an advanced level and Rust was their first language. I wonder how different they would view programming from what I started with primarily Python and expanding out to different languages as needed. Yeah, I wonder. Okay, so anyway, writing a Rust program. Next, make a new source file and call it main.rs. Let's do it. Maybe we'll just literally make it for the moment. So for those not familiar, The command touch and then a file name in bash means make an empty file, basically. So there's nothing in this file. And you can see that, you may or may not see something like this depending on what you've got set up, where I'm getting this immediate thing that tells me a little crab being like, by the way, you're in a path with like some Rust stuff, and it's version 1.88 of Rust that we got here. I don't know if that's like the compiler version. I thought that was a different version. Somebody could go back and look, but this may be the version of Cargo or the compiler or something. I'm not sure. Okay, so what else? What else do we got here? We've made the file. Now, if you're using more than one word in your file name, the convention is to use an underscore to separate them. Yeah, I think that's a pretty good convention. I try to name most things according to this, like, snake case is what we call it with Python, and I'm not sure that Pythonistas are the only ones that call it snake case, but anyway, it's basically lowercase underscores in between. So we should call it like hello underscore world rs rather than hello world rs. Although, to be honest, I will often just say, like hello world rs without saying the underscore, even though I mean an underscore. Okay, let's actually write some code. Man, I'm getting excited to write some code. Are you ready to write some code? Let's write some code. Okay, so function main. Didn't that feel good? That's our first little piece of code. We got to write this main function. Okay, calm down. Let's write it all out calmly. Now open the main rs file you just created and enter the code in listing 1-1. So we got that started, but we got to put in the rest. So we got print line macro. We'll talk, I'm sure, about macros later. And we got the semicolon at the end because we need to, in Rust, specify the end of a statement. Great. So we've saved the file, and we can go back out to the terminal. Technically, I don't have to do that, and that's not normally how I do things, but that will work perfectly fine. Let's follow along. So save the file and go back to your terminal window in that path. And on Linux or Mac OS, enter the following commands to compile and run this. So the first thing is we're going to compile it. We go main.rs. Okay, what did that do? Created this main, this little compiled binary thing. And the next thing we can do is run it like this. And there's our hello world. It's almost like whatever we put in, oh, that's main itself. Whatever we put in here, as long as it's like a valid string, hello YouTube, for example. I just about wrote like Python. Main.rs, and we can compile it again, and we can run, main again, and now it's hello YouTube instead of hello world. So it's just going to print whatever the string is that we put in there, right? Okay, so on Windows, likewise, you call main rs, and then with a reversed direction, a / and a backslash instead of a /, we run our binary, and there's our hello world. Now, regardless of your operating system, the string hello world should print to the terminal. If you don't see this output, refer back to the troubleshooting part of the installation section for ways to get help. I think that was just like go to the community page, I think. So if hello world did print, congratulations, you've just officially written a Rust program. That makes you a Rust programmer. Welcome. That's so nice, but that doesn't mean you're a good Rust programmer, right? It's just like you've written a hello world script. I guess you've technically written some Rust code. I've written a lot more than just a hello world, and I still feel like there's a long way to go before I would say, oh, I'm like a solid Rust programmer that's got all of the main features to like a level of fluency where I'd say I'd mastered it or something, right? Like, where are you a Rust programmer? I think this is fine, by the way. I don't mean to be too elitist about the phrase or the words, but it's a very little modest step. It's not a big step. There are Rust programmers, and then there are people who can build useful things in Rust. Okay, so anatomy of a Rust program. Let's review this hello world program in detail. That's a pretty good idea. Let's do it. So the first little piece here that they're outlining is this main function. Is what it's typically called. These lines define a function named main. The main function is special. It is always the first code that runs in every executable Rust program. Here, the first line declares a function named main that has no parameters and returns nothing. Now, if I remember right, oh, it's about to say that. I was about to say the thing it says. If there were parameters, they would go inside the parentheses. No, that's not what I was thinking. I was thinking, I could be wrong, but doesn't this return a unit type? I don't think you have to say this ever for the main function, but I think it just returns the, like, it's happy with that. I think it just returns the unit type if I'm not mistaken. Okay, but by the way, conventionally you don't need to write the unit type for the main function, as far as I know. As far as I know, you're fine with not writing it. Okay. Okay, the function body is wrapped in curly brackets. Rust requires curly brackets around all function bodies. It's good style to place the open curly brackets on the same line as the function declaration and adding one space in between. Personally, I'm completely fine with this. Note, if you want to stick to a standard style across Rust projects, you can use an auto-formatter tool called Rust Format to format your code in a particular style. More on Rust Format in Appendix D. the Rust team, has included this tool with the standard Rust distribution as Rust C is, so it should already be installed on your computer. I'm not sure... I can't remember if my IDE thing is going to fix this automatically. Yeah, it does. So I've already got like some formatting stuff where if I really do some weird formatting like this, where it's like, why is this thing way down there? And then I save, it just fixes it. It fixes my incompetent typing, right? It's great, except for when it doesn't. Okay, the body of the main function holds the following code. Print line macro, hello world as a string, literal, semicolon to end the expression. Ooh, does this run? It's thinking, wow, it just ran. Sweet. I wonder if it's got a Vixer built into this. It's kind of a tangent for a second. So there's these things from the Python world called Jupyter notebooks, right? And inside them, they have this thing called a Jupyter kernel that really says how or what code gets directed to actually run. And for us Python people, by default, this is a Python interpreter, right? Or an IPython interpreter, which is kind of a weird emulator on top of a Python interpreter. It's kind of hard to explain. And you can actually have other kernels for other languages, like R is pretty popular in the data science world, but, you know, I did find one for R called a Vixer, or Vixra? I can't remember, a Vixer maybe. And so at one point I was playing with running Rust inside of a Jupyter notebook. Maybe we should do that again for a video sometime. Let me know in the comments if that's of interest, to get Rust inside of Jupyter notebooks. Okay, so... this line does all the work in this little program. It prints text to the screen. There are three important details to notice here. First, the print line bang calls a Rust macro. If it had called a Rust function instead, it would be entered as print line with parentheses without the bang. Okay, or the exclamation mark is what I mean by bang, by the way. Rust macros are a way to write code that generates code to extend Rust syntax. It's a bit convoluted, but basically these macros, like it said, are just commands that themselves are, I'm simplifying a bit, but they are fancy placeholders to replace the macro code with some actual Rust code. So it's kind of a weird technical point, but in a way, this print line thing is not a proper Rust command at all. It's an extra bit of stuff that the compiler or tools right before the compiler. I'm not sure which way it goes with Rust, but it's basically going to do a really fancy fill this thing in with some actual code in the Rust language. Hopefully that makes sense. I know it's a little weird. And we'll discuss them in more detail in Chapter 20. That's probably good, because it'll probably do a better job of explaining it than I just did. There are also lots of explanations, by the way, of this subject. One of the pretty good books, once you've gone through your first book, is this Rust for Rustaceans book that goes into some more detail on macros and other things. Maybe we'll do that sometime. But for now, Rust programming language, people. For now, we just need to know that using a bang or an exclamation mark means that you're calling a macro instead of a normal function, and that macros don't always follow the same rules as functions, which is probably an important thing to keep in mind, although I have to say that in this specific case, it will pretty much have the same look and feel as a function. The only thing that's different there is the bang. Otherwise, I mean, if you had written some Rust function that happened to be print line instead, this is what it would look like. And it's almost the same from a syntax point of view. Technically not the same, but you know, sometimes you can pretend that the macros are functions, but it is eventually important to understand that they're not normal Rust functions. Okay, second, you see the hello world string, right? And we pass this string as an argument to print line macro, and the string is printed to the screen. Third, we end the line with a semicolon, which indicates that this expression is over and the next one is ready to begin. Or I think also statement. Isn't it a statement? Like it's a... I don't know that this is evaluates to anything. Maybe I'm wrong. Okay, so third, we end the line with a... Oh, what did I miss? Okay, so most lines of Rust code end with a semicolon. Yeah. Facts. Facts and figures. So compiling and running are separate steps. You've just run a newly created program. So let's examine each step in the process. Before running a Rust program, you must compile it using the Rust compiler by entering the rustc command and passing it the name of your source code, like this. So you got rustc main. Let's go through the motions. We got rustc main.rs. There it is. We run it. If you have C or C++ background, you'll notice that this is similar to using GCC or Clang. After compiling successfully, Rust outputs a binary executable. Yeah, it's pretty similar, isn't it? You know the thing that... what I guess there isn't is like the shared object files as far as I've seen. Am I wrong about that? Maybe I'm wrong about that, but I haven't seen them yet. SO files. Maybe they do come up. I feel like I'm wrong on this. Okay, after successfully compiling, Rust outputs a binary executable. Yeah, and that's what this is. Not the output, but like the file itself, right? This main, and you can see this wild difference, right? Like the actual amount of instructions inside of one of these binaries is obviously a lot bigger than the number of instructions that are, or the amount of like sheer data symbols, whatever, that's in your main RS, right? The main RS was just a little bit of plain text, and plain text is pretty cheap. But there's a lot of things to basically tell your computer to do all of these things. It's actually pretty cool. Okay, so what's next? Yeah, on Linux and Mac OS and PowerShell on Windows, you can see the executable by entering the ls command in your shell, and I'm just skipping ahead because I don't know how to follow a book. All right, on Linux and Mac OS, you'll see two files. With PowerShell on Windows, you'll see the same 3 line files that you would see using CMD, the command tool, and with CMD on Windows, you would enter the following. So you got this dir /b % equals the blah, blah, blah. Okay. main.exe, a PDB file. So coming from a like biochemistry and a bit of bioinformatics kind of background, my brain just thinks of like protein data bank files, which is this absolutely is not, by the way. Completely different animal. And then we got this main.rs file. So this shows the source code with the RS extension, the executable file, main.exe on Windows, but main on other platforms. And when using Windows, a file containing debugging information with the PDB extension. Ah, that's what it is. It's a debugger. It's a debugging file. That's cool. From here, you can run the main or main.rs file like this. Let's do it again. Boop. Hello world, or hello YouTube. From here, okay, so we got that. If your main.rs is your hello world program, this line prints hello world to your terminal. Yes, it does, except the change we made, but that's fine. If you're more familiar with dynamic languages such as Ruby, Python, JavaScript, you might not be used to compiling and running a program as a separate series, separate steps. Yeah, totally. So the weird little tidbit, by the way, about Python, a lot of people think that it isn't a compiled language, but depending on what you mean by compilation, and actually in the more standard computer science sense of compilation, it is a compiled language. You compile your Python code first to Python bytecode, and then from there, the interpreter knows what to do on the system with the Python bytecode. Fun facts. If you didn't know that before, now you know that Python is both. It's both compiled and interpreted. Happy days. Okay, so Rust is an ahead-of-time compiled language, meaning you can compile a program and give the executable to someone else, and they can run it even without having Rust installed. If you give someone a .rb, .py, or .js file, they need to have Ruby, Python, or JavaScript implementation installed respectively. But in those languages, you only need one command to compile and run your program. Everything is a trade-off in language design. I love that point so much. The idea that there's like a silver bullet is just wild, that idea is still around, even though if you go back to, where is it? Oh my goodness me, I lost a book. I have solid, oh there it is. There it is, Mythical Man Month. I mean, this book is a classic collection of essays that pretty much, as far as I know, was the progenitor of this topic of that there are no silver bullets in software. And I'm sure the ideas for what it's talking about in terms of trade-offs is an older idea. But yeah, I mean, there's just no perfectly correct answer when it comes to a lot of complex tools and system design and stuff. There's no overall best of all worlds kind of answer, unfortunately. Okay, but you can pick the things that you want to have and the things you don't want to have among the options, and that's as good as it gets. Okay, so just compiling with Rust C is fine for simple programs, but as your project grows, you'll want to manage all the options and make it easy to share your code. Next, we'll introduce you to Cargo, the Cargo tool, which will help you write real-world Rust programs. Absolutely. To be honest, once I learned some basics of Cargo, I never really went back to using Rust C. Not that I wouldn't again if it was needed, but yeah, Cargo's pretty great. If you're doing Rust, especially if you're starting in Rust, I don't see why you wouldn't use Cargo to learn. And Cargo perhaps to even use for prod, like for building stuff for prod. Okay, hello, Cargo. What do we got here, Cargo? Cargo is Rust's build system and package manager. I would also describe it, maybe they'll get to this in just a moment, but it is kind of a wrapper command that references other CLI commands, including Rust C, right? And so it does do package management, it does handle building, but you can also use it to call a formatter, call a linter, and other kinds of things that Cargo is like a command line that has a bunch of subcommands that allow you to basically manage more of the work than just building and package management. But hey, anyway, it's pretty great. We'll get into it over time. Most Rust stations use this tool to manage their Rust projects because Cargo handles a lot of tasks for you, such as building your code, downloading the libraries your code depends on, and building those libraries. We call the libraries that your code needs dependencies. Yeah, I mean, that's a pretty common term. If you're not familiar with hearing about dependencies for a library or a package or whatever, they are just themselves usually considered to be other libraries or packages that your package or tool needs. Okay, so the simplest Rust programs, like the one we've written so far, don't have any dependencies. If we had to build the Hello World project with Cargo, it would only use the part of Cargo that handles building your code. As you write more complex Rust programs, you'll add dependencies. And if you start a project using Cargo, adding dependencies will be much easier to do. Yeah, I agree. Because the vast majority of Rust projects use Cargo, the rest of this book assumes that you're using Cargo too. Let's do it. Let's be Cargo people. Although let's not be a Cargo cult. That's a different thing, believe me. Okay, Cargo comes installed with Rust if you used the official Rust installer discussed in installation. If you installed Rust through some other means, check whether Cargo is installed by entering the following in your terminal. To be honest, I don't remember how I installed Cargo, or Rust Cargo, whatever. but I'm pretty sure I got this. I got it. I got that cargo. You should too. If you see a version number, you have it. If you see an error, such as command not found, look at the documentation for your method of installation to determine how to install cargo separately. Cool. I feel like for beginners, for the most part, including myself, I'd be like, you know what, you should probably use cargo. Like, it's just a simple option that covers most of the development flow when you're working locally and you're just trying to build something in a language and figure out the language. I think cargo is a good bet here. You're going to like some of the commands, I think. So, creating a project with cargo. Let's create a new project using cargo and look at how it differs from our original Hello World project. Navigate back to your project's directory or wherever you decided to store your code. Then, on any operating system, run the following code. Oh, that's a nice thing too. It kind of standardizes across, you know, the different tools you're using. So, we'll go cargo new, hello, cargo. And look at that, creating binary application hello cargo package. Note, see more in cargo.toml keys and their definitions at the http blibbity blabbity. Let's take a real quick peek. We're not going to actually read through all these options right now, but maybe this is a book we'll read in the future. If there's any interest in this, in the cargo book, let me know in the comments. But basically, this is a book that goes through all of the things that cargo is and all of the ways you can use cargo for not just the basic stuff, which is mostly what we're going to cover in the Rust programming book, but also advanced features of how to set up stuff and run stuff and integrate different kinds of tools and whatever. Okay, but we're not doing that right now. Back to the Rust programming language. So we just built this thing. We just made this path with some goodies in it, and we're going to find out what we have in here. So now, not only do we have this little crab, but now we've also got this little box with a version number here, and that's signifying that we have cargo here. This is basically a Rust crate or package or whatever. And I was about to jump into talking about the files, but I bet you we're going to go through all of it, so I'm going to be good and just follow along. Okay, let's do it. So the first command creates a new directory and project called Hello Cargo. We've named our project Hello Cargo, and Cargo creates its files in a directory of the same name. Go into the Hello Cargo directory and list the files. We just did that. Or we could even call tree. You can see there's actually not a lot in this basic project. You got source, and inside of source, there's one of those main.rs files, just like the one we made a hot minute ago. Okay, so you'll see that Cargo has generated two files and one directory for us: a cargo.toml file and a source or src. At some point, you just start saying source, but it's an initialism for source is src, with a main.rs file in it. Nice. It has also initialized a new Git repository alongside the Git along with a git ignore file. Git files won't be generated if you run cargo new within a new Git repository. You can override this behavior by using cargo new -vcs for version control system equals git. That's interesting. I wonder if it actually supports other things like Mercurial or something like that. But all right. So this, by the way, is inside of a Git repo. So if I ls with -a to show hidden files, there's no .git here because we're already inside of a Git repo. All right. But it may look different on your system. Maybe there is a .git, depending on where you put it. So there's a little note here. Let's read it. Git is a common version control system. Gosh darn heck it is. You can change cargo new to use different version control systems or no version control system by using the --vcs flag. Run cargo new --help to see available options. It will look really quick, real quick, so quick. There's a lot of options. Where is the VCS one? There at the top. Initialize a new repository for a given version control system, overriding a global configuration. Possible values git. HG, I'm guessing, is Mercurial. I'm not sure what that one is. Never heard of that. Pidgel, Fossil. I don't actually know these. Maybe I should Google them. And then none. If you know what these are, let me know. Let me know in the comments what you think they are. Okay, let's move on. Open cargo.toml in your text editor of choice. It should look similar to the code in listing 1-2. All right, let's do it. Let's go cargo.toml. So there's not a lot to this at the start. You got the name, version, edition, got that special word we said before, dependencies. Let's keep going. Okay, it's going to tell us what all these things are. So this file is in the TOML, Tom's Obvious Minimal Language Format, which is Cargo's configuration format. Python these days also uses TOML files. We have a pyproject.toml file, as it's not an exclusive type of file, but it's a file that's commonly used now for packaging. Okay. The first line, package, is a section heading that indicates the following statements are configuring a package. As we add more information to this file, we'll add other sections. Sounds good. The next 3 lines set the configuration information Cargo needs to compile your program. The name, the version, and the edition of Rust. We'll talk about the edition key in Appendix E. I'll just say really briefly that editions are like these super versions. So you got the version of your crate or whatever you're building, package or a source file, your project. But then there's also the version of the compiler. But there's also this generalized like specification of the language itself is allowed to change, which is coupled to the compiler, but is eventually indicated by these editions. So you see this is 2024 because that's when the latest edition came out, was targeted at 2024, and that they don't come out every year, if I remember right. They don't come out every single year. The last one I want to say was, I can't remember. Was it 2020, 2021? Somebody let me know. The last line, dependencies, is the start of a section for you to list any of your project's dependencies. In Rust, packages of code are referred to as crates. We won't need any other crates for this project, but we will in the first project in Chapter 2. I'm looking forward to Chapter 2 because Chapter 2 says programming a guessing game, and like, isn't that just it? Time to make some guesses. Okay. We won't need any other crates for this project, but we will in Chapter 2. So we'll see this dependency section then. If I remember right, one of the things is it's going to generate some random things. And so we'll need, the rand crate to generate random numbers for us. I don't think random number generation is like standard library stuff, if I remember right. Okay, so if we open up the source file, there it is. This should look quite familiar. We got our main function. We got our print line macro, hello world. This time it doesn't say YouTube. That's all well and good. So Cargo has generated a hello world program for you, just like the one we wrote in listing 1-1. Now the kind of weird thing though is that almost certainly hello world program is not the first, program that you would ever write, but it's just kind of expected, I think, that you hit like a level with Rust where you just simply replace whatever is here by deleting it and then writing whatever. That's quick to come. But then there's also a level where you're just like, you can create templates for projects to say this is the stuff that should be generated. And that's, I think, where a lot of us end up is going, we don't want to write everything from scratch. There might be some more project stuff that we want to just have generated for us. But that's not what we're doing here. We're going to do the simple, straightforward path here. Okay, so far, the differences between our project and the project Cargo generated are that Cargo placed the code in the source directory, and we have a Cargo TOML configuration file in the top directory. Cargo expects your source files to live inside the source directory. The top-level project directory is just for README files, license information, configuration files, and anything else not related to your code. Using cargo helps you organize your projects. There's a place for everything and everything in its place. Mise en place. Just, that's the thing right there. If you started a project that doesn't use cargo, as we did with the Hello World project, you can convert it to a project that does use cargo. Move the project code into the source directory and create an appropriate cargo toml file. One easy way to get that cargo toml file is to run cargo init, which will create it for you automatically. Fair enough. So, building and running a cargo project. Now let's look at what's different. Because like so far, what's the benefit here? It created some files for us. I guess it's like a small project template generator. What else can this thing do? Now let's look at what's different when we build and run the Hello World program with cargo. From your Hello World cargo directory, build your project by entering the following command. Let's do it. We're in the right place. We got that cargo lock, which we didn't make, and don't touch it. Okay, so let's run cargo build. Look at that. It just compiled something. It says compiling. Hello cargo. Version, this is the version of our package in our cargo file. This is a giant path saying where we're at right now in my computer, which we don't need to care about. And we finished a dev profile, unoptimized, and debug info targets. And it made it in 0.17 seconds. Okay, so admittedly, 0.17 seconds, not necessarily a win compared to just printing hello world in like a Python script file, right? But you can write programs that compile to binaries that will be fast, very fast sometimes. Okay. So this command creates an executable file in a target debug hello cargo. Right, let's verify that that's there. ls target debug hello cargo. There it is. Or if you're on Windows, target debug hello cargo.exe. Great. And we should be able to run this. So let's run it. Look at that. That's a hello world right there. We just did it. So if all goes well, hello world should print to the terminal. Run cargo build for the first time. Running cargo build for the first time also causes cargo to create a new file at the top level, cargo lock. This file keeps track of the exact versions of dependencies in your project. This project doesn't have dependencies, so the file is a bit sparse. How big is it? It's actually, yeah, it's not a huge file. Okay. Where was I? I was just curious about the size there. The file keeps track of the doesn't have, sure. You won't ever need to change this file manually. Cargo manages its contents for you. Yeah, it'll start keeping track of things like hashes for your different dependencies and the versions and all that jazz. And so it's just a way of making sure that you've managed the dependencies in some consistent way. We just built a project with cargo build and ran it with the target debug hello cargo. But we can also use cargo run to compile the code and then run the resultant executable all in one command, which kind of saves us from having to, you know, run two separate commands or write out both commands in the same line with like a semicolon to separate in bash or whatever. This is just one simple command. We can go cargo run, we'll do the compilation and then immediately run the executable, the main RS file. So that's kind of nice. And so we immediately get this hello world. And maybe I'll show you one quick little thing, which is, let's say that I'm actually just developing from, oops, I don't want to go to target. I want to go to source. That I might actually just run it like this from my editor itself. So I'm not necessarily even leaving the source code file, the main RS file, just because I want to do a quick check. Just a little tip. Okay, so notice, so using cargo run is more convenient than having to remember to do cargo build and then use the whole path to the binary. So most developers use cargo run. It's definitely what I use. Definitely Not a huge time saver, but you know what? It is a time saver, I think, in the long run. You run that command many times. So notice that this time we didn't see output indicating that Cargo was compiling hello cargo. Cargo figured out that the files hadn't changed, so it didn't rebuild, but just reran that binary. If you had modified the source code, Cargo would have rebuilt the project before running it, and you would have seen this output. So let's do that right now. Let's make some kind of modification. Maybe we'll go back to the hello YouTube thing, and then we go cargo run. This time you see there's this compilation step, which was successful because we didn't really make any breaking changes there. So here's their example. It looks similar. Compiling, finished, running. Hello world. So Cargo also provides a command called cargo check. Let's run that. Cargo check. And it just simply checks that it's code that will make the compiler happy, that is syntactically valid, as well as some other kinds of checks. So let me see what it says here. This command quickly checks your code to make sure it compiles, but doesn't provide an executable. And that's because checking that the code is actually correct for the compiler can be done more cheaply than doing the compilation. Hopefully that makes sense. So why would you not want an executable? It's probably about to explain what I just said, but in better words. Often cargo check is much faster than cargo build because it skips the step of producing an executable. If you're continually checking your work while writing code, using cargo check will speed up the process of letting you know if your project is still compiling. As such, many Rustaceans run cargo check periodically as they write their program to make sure it compiles. They then run cargo build when they are ready to use the executable. So let's recap on what we've learned so far about Cargo. We can create a project using Cargo build. We can build a project using Cargo build. We can build and run a project in one step using Cargo run. We can build a project without producing a binary to check for errors using Cargo check. And instead of saving the result of the build in the same directory as our code, Cargo stores it in the target debug directory. An additional advantage of using Cargo is that the commands are the same, no matter which operating system you're working on. So at this point, we'll no longer provide specific instructions for Linux and Mac OS versus Windows. Isn't that great? I mean, we've barely scratched the surface of this book, and we're already at a stage where we don't have to worry about which operating system we're on. Mostly we just have to get started with getting the installation down right, and then you're basically done as long as you're willing to use Cargo. So, building for release. When your project is finally ready for release, you can use cargo build -- release to compile it with optimizations. Let's do it. Cargo build release. Notice that it now says optimized instead of whatever it normally says, unoptimized, and it no longer says debug mode as well. That's pretty great. And there's a good reason for this, which I'm sure it'll explain in just a moment here. So this command will create an executable in target release instead of target debug. So again, we should be able to go target release, and where is our hello cargo, hello world. Fantastic. Nice. The optimizations make your Rust code run faster, but turning them on lengthens the time it takes to compile your program. So this is why there are two different profiles, one for development when you want to rebuild quickly and often, and another for building the final program you'll give to a user that won't be able to rebuild the system repeatedly and will run as fast as possible. If you're benchmarking your code's running time, be sure to run cargo build release and benchmark with the executable in target release. So I think that the timings do show. In fact, actually, I think we can also go straight to cargo release as well. Yes? No? Oh, cargo. That's definitely not valid. Cargo run release. So you could also do a release build and run right away, although I'm not sure that that's quite as common of a use case. Anyway, this is why there are two profiles. Okay, we already read all that. That's good. Cargo as convention. With simple projects, Cargo doesn't provide a lot of value over just using Rust C, but it will prove its worth as your programs become more intricate. Once programs grow into multiple files or need a dependency, it's much easier to let Cargo coordinate the build. Even though the Hello Cargo project is simple, it now uses much of the real tooling you'll use in the rest of your Rust career. If you have a Rust career. In fact, to work on any existing projects, you can just use the following commands to check out the code using Git. Change to that project's directory and build. So this is pretty cool, but perhaps you could do some wildly dangerous things of just grabbing stuff right off of Git, going into that project and immediately building. I don't know that that's always a secure thing to do, but it's a thing you can do. So for more information about Cargo, you can check out its documentation. We did take a little quick sneak peek, but I think that's an entire other book to read. So, summary. You're already off to a great start on your Rust journey. In this chapter, you've learned how to 1. Install the latest stable version of Rust using Rust Up, and 2. Update to a newer version of Rust. 3. Open locally installed documentation. 4. Write and run a Hello World program using Rust C directly. And the last bullet here of create and run a new project using the conventions of Cargo. This is a great time to build a more substantial program to get used to reading and writing Rust code. So in Chapter 2, we'll build a guessing game program. If you would rather like to start by learning how common programming concepts work in Rust, you can skip over to Chapter 3 and then return to Chapter 2 later. Cool. I think we will go through Chapter 2 in the next video. This video was longer than I expected, so I think I'm going to break it up into even smaller little sections for most of these videos if I can, although we'll see how long that programming guessing game is. If it's short enough, we might do it in one video. So, with that, hopefully you learned a few things about getting started with Rust, of how to install, of how to do your first Hello World directly with the Rust C compiler, and then also a little bit of learning Hello Cargo kind of stuff, of using Cargo for your basic workflow of using the language, using the tool to set up a project, and then be able to basically compile and run that project. Great. With that, I will see you in the next video. Take care.